Hello guys, David down for another video. Apologies for the delay. I do understand that um when these videos take long to come out, then it's there's sort of a breach in the learning because they do follow each other, and then them taking long means you can't, if you're following them, then you can't move at the pace that you guys are want to move at. I do apologize for that, but I had to be away. Anyway, as you see, we're doing a for loop in this video. Now, it's pretty simple, the for loop. There is just one part of it that is not very intuitive, that we probably need some explaining, which I will do. So just pay attention a little bit. So you'll see here, I've initialized a list, right, into a variable called myList. List, because list is probably the data structure that you will use a for loop the most for. And you'll see I've said here for your variable. I'll explain what this means. In your data structure, do this. Now, this is not Python code. This is kind of pseudocode. It's not even pseudocode. I'll explain in a later video what pseudocoding is. But as far as Python code is concerned, this is how you would do a list. So you would say for I in my list, which is the name of the list, and you would probably need to first declare the list, otherwise we'll get an error that we haven't declared. So let me run this so that my list exists now. And then for I in my list, print I like that. So my list is this list here, right? Which is a list that has got numbers in it, list of integers. You could call it an array of integers as well. Lists are also typically called arrays. So if anyone calls a list an array, don't be confused. My list is this list, print I. So if I run this, what will happen is 1, 2, 3, 4, 5, 6, 7, 8, as they appear in my list, one underneath the other. So a for loop visits all the elements of your list. So I don't want to say data structure because that would be incorrect. Let's think of it as a list for now. Yeah, I will explain how it might not be a list, but for the most part, you'll use a for loop to loop through a list. For I'd say 80% of the things you're going to do, you'll use a list for a for loop. If ever you're using a string in a for loop, you'll probably have to change the string into a list and then loop through the list and then maybe change it back or something of that nature. But for the most part, as I say, you'll be using a list like this. So what it does is a loop, by convention, the word loop means go through everything, right? Go through everything until given an instruction or until something, right? So for I, now let me quickly explain what I is. I is sort of like a placeholder variable. And when I say variable, I mean variable, like my variable, like this, how I can put anything in my variable. I can put a string. It's a placeholder variable that you can call whatever you want for the purposes of a for list, for a for loop. So in this for loop, I'm calling the elements in my list I. So when the for loop visits the first element, which is 1, and then 2, and then 3, and then 4, so it visits these things, a for loop is going to visit every single element of the list and then assign it the variable I. So it's going to come to 1. 1 is I. What do you want to do for I? You want to print it. So when it's at 1, basically what's happening is something like this. This is I, right? Then this is I, 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 then this is I. So all these things will have a chance to be I and a chance for something to happen to them. So I'm saying for I in my list, print I, this variable I've created, print I. Now again, I could call this anything. I could call this ABC. I could call this anything, so long as it's consistent with here, right? So obviously that's not consistent, but let's call it num. Now the reason I'm going to say num is because a lot of the time with the for loop, you want to call the variable something related to what it's going to loop through or what the data structure is. So this is a data structure that's a list of numbers. So you would say something like for num in my list, and you wouldn't call my list probably wouldn't be called my list. Remember when we started with variables, we said that it should be called something that relates to what's in it. So it could be my list, but you could call it numbers, and then you would say for num in numbers print num. So we'll get the same thing here. Remember, num is, I can call it whatever, but this needs to be the list I've created. And then what do you want to do with these things which now have mapped to this variable? And we should get this exact same thing, print num, and it's gonna complain because numbers is not declared. Okay, cool there. And we get 1 2 3 4 5 6 7 8. Now you also then can have different things in a list. It doesn't have to be numbers. So I could have one, and then I could have a name like this. I could have a floating point number, not like that, like that. And no matter what, I mean, you wouldn't call this numbers, then you'd call this something else. Let's call it stuff. So for stuff, and you probably wouldn't call this num, you probably call this for items and stuff, print items. And it's going to come into the list, and then this is going to be items. It's going to print me one. Then this is going to be items. It's going to print me that. Then this is going to be items. It's going to print me that. It loops through everything that's in a list and then prints you the list. Now what I'm going to do is I'm going to put these things and make them numbers again. Or in fact, we can actually keep that floating point. 55, let's just say. And then I'm going to come again for num, just because it relates to what's in the list. Again, that first variable can be whatever you want. So for num in numbers, can't be stuff anymore because stuff doesn't exist. There's no such list as stuff. So for num in numbers, so how we had it, you don't only have to print the thing. So I mean, if I print it like we did, again, I didn't redeclare this. So if we just print it, right, we just get the stuff. You can do a whole lot of stuff in this indent. So say, for example, I know that this is a list of numbers. I could print, I could print num times 2. So it's going to come to 1. 1 is num. And then 1 times 2 is 2. It should print me 2. Then it's done, because that's the instruction you gave it for the first variable num in numbers. It's then going to come to 21. 21 is then num. 21 times 2 should be 40, whatever, 42, right? And then etc, etc, etc. So let's check that this works. Let me make sure that I've done this properly. And then for num in nums, for this, and this, which is in the numbers list again, so this has to be correct. This can be whatever you want, so long as whenever you use it in your indented for loop, again, the indent is absolutely important in Python. The colon is important, and whenever you're printing something, obviously you know it has to be within these brackets. Every time it visits the thing that's in here, we must multiply by 2 and print. Now, you can also have an if statement indented inside your for loop. So let me change numbers, right? And then let's have a list that says 1 2 3 4 5 6 7 8 9 10. Let's have 20. Let's have 100, 101. So this is just random, just top of my head. So for num in numbers again, before I carry on with this if statement, we've got a list full of numbers, right? So num's going to be that, then that, then that's going to be everything in this list. It's going to visit, num is going to represent everything in this list, and then you're going to give an instruction such that the indent that's what the indent demonstrates, that, okay, for num in nums, what's the instruction? Okay, well, for everything in this list, if num, right? So again, so if 1, then 2, then 3, then 4, when I get there, so this is going to be num. Just want to drive this point home. So this is going to be num, then 2 is going to be num, then 3. All of these are going to have a chance to be num. If num modulo, now I'll explain what modulo is in a second, equals 0, then print num, right? So I've said for all these numbers, when you visit them, check first before you do any printing. So there's something in between the for loop and the print. I've got an if statement I first want to check. Now remember, an if statement will only run if it's true, right? Now let me for a second explain what this thing means, modulo. Modulo returns to you the remainder of. So if I say 30 modulus 2, 2 goes perfectly into 30, there's no remainder, so the answer here is 0. It's very handy for if you're checking whether something is an odd or an even number. So if I say here print 30 modulo 2, the answer will be 0 because 2 goes cleanly into 30 with no remainders. 30 happens to be an even number, right? So if I print this, I get 0. If I say 31, then I get the number 1 because 2 goes into 30 however many times, 15 times, and then there's a remainder 1. If I want to check if a number is even, what could I do? I could check 3 because 3 is an even number. And I know that if I get 0, there's no remainders, the number goes clean, 3 goes cleanly into the number's an even number. So this is 0, which means this is not an even number. 31 gives me remainder 1, suggests to me 31 is an even number. Now, you won't typically in use cases, you'll get it like a variable. So some variable will have a number in it that you don't know, maybe a number like this, and you might need to check if this number is odd or even for you to do something with it. So print num modulus 2, right? So I know that this ends in 5, so it's not an even number. So this gives me remainder 1, so I know that this number is not even, right? I will do another video on modulus, another quick video where we focus on modulo. So for num in numbers, right? So there's my numbers list. If the number modulo 2 is 0, so I'm checking for an even number. Just think of modulus like that. For most of the time, you're going to use modulus to check if a number is odd or check if a number is even. So if the number modulus 2 is 0, that means the number is even, then only print the number. Else, let's have an else statement. Print that is not even. So let's see what happens when we print this. Let us run this and then run this. Cool. So it comes to 1 and 1's not even. So it says that's not even. Then it comes to 2 and you said to me that if it's even, I must print the number, right? So it prints 2. Then it comes to 3. It checks this if statement, which is false. So it comes to the else clause. I hope you guys have watched the video on if else so that you can understand this properly. It prints that is not even. Then 4 is the next number, which is even. And you said if the number modulo 2, which means the number is even, I must print the number. So I'm going to give you 4. Now num is 5. If num, which is now 5, modulus 2 is 0, which means it's even. If that's the case, print the number. If it's not, that's not even. Now we know 5 is not an even number, so it prints that is not even. What came after 5? 6. So the for loop loops through every little thing that's in your list, and then you give it instructions. The instructions don't have to be this complicated. It could be a simple instruction like this. You don't even have to have an else statement. You can just stop right there. So if the number modulus 2 is 0, print the number, then it will just print the even numbers.